Hi everyone, I'm delighted to be speaking at Kubernetes Days Sri Lanka 2022. My name is Dakshitha Rathn and I am a developer advocate at WSO2. And I'll be talking about how you can simplify network services for real-world cloud-native applications with the Ballerina programming language. So, what are network services? They're pretty much APIs or microservices, which are core components of cloud-native computing. Breaking applications into small, loosely coupled parts makes it easier for developers to build agile and resilient software. So these network services can be in the form of a REST API, a GraphQL API, or a gRPC service, and so on. So what is it like to build network services? Distributed applications are complex. So when you're dealing with a network, errors are a normal part of doing business, especially when you consider the 8 fallacies of distributed computing that you can see on this slide. To build cloud-native applications with network services, developers must be well-versed in the right tools, programming languages, and development and deployment techniques. So, in light of this, what's the role of the programming language that you use to develop network services? Can you use any mainstream popular programming language to build your service and APIs? Yes, most of the time. Some are more suited than others, but are these languages truly cloud native? Or are they repurposed for the cloud with libraries and frameworks? What if developers want to go beyond the scope of the framework? Do developers stick to these libraries and frameworks nevertheless because they're familiar with the underlying programming language? And some other questions to ask are, do these languages treat the network aspects as an inherent part of the language? And what about data handling? How do they serialize data on the wire to data in memory? So I can safely say that none of the mainstream programming languages as of now have been purposely built with the right level of abstractions to ease the use and creation of network services. Enter the Ballerina programming language. So the key goal of the Ballerina language is to significantly simplify the creation, integration, and usage of APIs or microservices, be it REST, GraphQL, or gRPC. The latest Swan Lake release comes with many remarkable features that will be appreciated by any service developer. So instead of repurposing existing technologies, Ballerina is purposely designed to build interactions over the network, abstracting away the hard parts and allowing you to focus on core business logic. So I'm going to talk about a few characteristics or offerings of the Ballerina language that makes it a really good programming language to program your services. So the first one I want to talk about is the Ballerina language being network-oriented. So along with a network-aware type system, Ballerina comes with fundamental syntax abstraction for working with network services. So Ballerina has this concept, or it accommodates the concept of a service, and a service can be written in just 3 or 4 lines of Ballerina code. And services in Ballerina are powered by listeners and libraries, and so that's how a service can work, right? And because Ballerina's service approach is coupled with its unique wire-oriented type system, you can generate an interface description from the Ballerina code. So this can be an open API spec, an async API specification, or a GraphQL specification. So you can actually write regular Ballerina service objects and generate your client code. So the combination of these features enables cloud integration to work smoothly. And then you also have client objects. So like you have service objects, you also have client objects to consume remote services. The outbound network interactions are represented by client objects, and clients have remote methods that represent outbound interactions with a remote system. And you also have sequence diagrams for network interactions. So I'll be showing that in one of the later slides. And Ballerina is data-oriented and is not object-oriented. In network interactions, the object-oriented approach bundles data with the code, which is not the most optimal way to send data across widely distributed networks of microservices and APIs. And that's why Ballerina comes with a network-friendly type system with powerful features to handle data on the wire. Ballerina's plain in-memory data values are pretty much in-memory JSON. So this allows a JSON payload from the wire to come immediately into the language and be operated on without transformation or serialization. We know that JSON is the most widely used format in the network today. So Ballerina also comes with a set of language features for working on data, out of which the integrated query feature stands out. So this feature basically allows you to query the data using an SQL-like syntax or query. So basically, query expressions contain a set of clauses similar to SQL to process the data. And there's also a table data, which makes it easy to work with relational and tabular data. So Ballerina allows you to do enterprise-grade development. So that means basically to run services reliably, securely, and safely for a long period of time on multiple environments. Ballerina provides these capabilities. So when you're talking about configurability, Ballerina takes the concept of configurability into the language. And that allows us to keep the same program and move from one environment to another environment without being explicit about what the dependencies are. And then you have transactions. Writing Ballerina programs that use transactions is quite straightforward because transactions are a language feature. Transactions in Ballerina also work well with the network interaction features. That means the clients and services to support distributed transactions. A lot of effort has been taken to handle errors reliably and consistently within the Ballerina language. You have to be able to look at the program and understand if there is an error, where an error could take place, and how the flow of control is going to change. So without using exceptions, Ballerina allows the developer to use the error data type with explicit error control flow. When we talk about concurrency is a fundamental requirement in the cloud because your network operations have high latency. So using threads and strands for asynchronous communication, Ballerina provides a simpler and intuitive approach to concurrency. Then it's important to highlight that while Ballerina provides better ways to write services, it also comes with a subset of features that are familiar to a programmer of a C family language, such as Java, C++, or C. And basically the code is not something that's alien to you. You can understand how it works, right? So Ballerina supports generating Docker and Kubernetes artifacts from code with simple configurations. And this simplifies the experience of developing and deploying Ballerina code in the cloud. To deploy your code into different cloud platforms such as AWS and Microsoft Azure, annotations on service objects are used to enable easy cloud deployment. The Ballerina compiler can generate artifacts such as Docker files, Docker images, Kubernetes YAML files, and serverless functions. So, like I mentioned before, Ballerina has a graphical aspect to it via sequence diagrams. So Ballerina provides an intrinsic graphical view. So the unique graphical view of Ballerina wasn't an afterthought. It was, in fact, it has been designed deeply into the language in order to provide real insight with respect to a functions or a services, network interactions, and their use of concurrency. So a sequence diagram is the kind of diagram that works best for that. So you can see that this is like a mix of a flow chart and a sequence diagram. So a function in a Ballerina program has equivalent representations in both textual syntax and as a sequence diagram. That means you can switch between the two views seamlessly. And in addition to the powerful language features, Ballerina is batteries included, which means that the language comes with a support system, right? And that means that the language comes with a rich standard library with libraries for network data, messaging, and communication protocols such as HTTP, HTTP2, NATS, gRPC, WebSub, WebSocket, etc. And we have a package management system which allows you to pull and push your Ballerina packages. Then there's a testing framework, and we have extensions or plugins for popular IDEs, the most notable one being the Visual Studio Code plugin, and structured documentation among other tools to support the language. And if you want to learn more about the language, the website is the best place to go. It's got a wealth of resources and documentation to help you get started. And with that, I'd like to conclude my 10-minute presentation on the Ballerina programming language. I hope it was useful learning about the Ballerina language. Thanks for joining.